Okay, how many people have the multiplier app on their phone? Yay, good. We have over 100,000 downloads, and it's free. I wish I would have charged $1 or something, and we would have made some money. But anyway, so I'm going to give you just a quick, brief update on the multiplier app and what that's all about. We know there are many different ways to predict limb length discrepancy and timing of epiphysiodesis. When I was a fellow, we used the Moseley straight line graph because I did my fellowship in Toronto where Moseley was on staff. The Green-Anderson charts have been around since the 50s. Malcolm Menelaus from Australia came up with the rule of thumb, which everyone uses, and the multiplier method is something that we came up with about 25 years ago. So all of these methods, without exception, only apply to Shapiro type 1 curves, which you tend to see this straight upward slope pattern, which happens in neuromuscular disease, congenital diseases, epiphyseal rest. But so many of the other types of patterns of limb length discrepancy that we see after, say, inflammatory disease, rheumatoid arthritis, you can't use them. So it's just for the Shapiro type 1 curves, just FYI. Moseley's trick was he took the Green-Anderson growth curve, which has this kind of funny shape to it, and he just fiddled with the arithmetic scale to make it into a straight line graph. That was the whole basic change that he did. And so this is what I grew up doing, these straight line graphs. You had to see the patient 3 separate times, and when you had 3 separate visits, you could draw these lines and then make predictions. Malcolm Menelaus came out with some very simple rules. He said girls stop growing when they're 14, boys stop growing at 16. Talking about the legs, not the spine. And the distal femur grows 9 millimeters per year, the proximal tibia 6, and the distal tibia and proximal femur 3. So they're very easy numbers to remember, 9, 6, and 3. And so you could calculate how much growth would be lost if you did a fusion, say, of the distal femur, 9 millimeters per year, and you could predict the effective timing of epiphysiodesis based on these very simple numbers. That's why it's a rule of thumb. You don't even need a calculator for that. Dror Paley and I published on the multiplier, which was also, like everyone else's work, was based on the Green-Anderson tables. And these were our multiplier charts. That was published 25 years ago. This is the original data of Green and Anderson on the length of femur and tibia in children at different ages, and that came out of Boston in the 1950s and a series of kids who had polio in one leg. And this is the raw data from Green-Anderson. It was divided by, say, mean lengths of the femur versus plus or minus 2 standard deviations at all different ages from 1 to 18. So, for example, and this is all we did to come up with the multiplier, we took the length of a femur at maturity, which was 43 centimeters, typical femur, in a boy and a girl, rather. And then what it was at age 8 was 32 centimeters. If you take this divided by this, you come up with a multiplier. In other words, the length of a femur times that multiplier will give you the length at maturity. So the multiplier for an 8-year-old girl would be 1.33. And so if you multiply any of these numbers by 1.33, you'll get their length at maturity. Because it really doesn't matter if they're tall girls or short girls, 2 standard deviations above or below, it's the same multiplier. So how do we use this clinically? This is our multiplier charts, and it's a different one for boys and girls. You have to have a boy and girl chart. But if you take like a 7-year-old boy, for example, and they've got a 6.3 centimeter leg length discrepancy, the multiplier for age 7 is 1.570. You multiply that by the leg length discrepancy, and you get a predicted discrepancy of 9.9 centimeters. And there's a whole derivation as to why that's true for discrepancy as well as for actual length. I won't bother to go into that right now. When we looked at, we took the Green-Anderson data and looked at it many different ways. It turns out that the multiplier for the femur and for the tibia was the same. This is the curve for the femur and for tibia. They're superimposed. So you don't need a different multiplier for femur and tibia. It's the same, total leg, femur, tibia, individually, all the same. And then we didn't just go by the Anderson-Green data. We also looked at all kinds of other databases that are out there. And many of these databases are from China or from Scandinavia or South Africa. And so in many different races, ethnicities around the world, the multipliers came out to be pretty much the same. So that's sort of an interesting thing. It didn't matter if you're a Chinese boat person who doesn't wear shoes and just climbs around the boats all days, or if you're in South Africa, or if you're in Denver, Colorado, the multipliers are the same. And then there's even databases, believe it or not, of anthropologic sites, Indian burial sites that go back as far as 3,000 years ago. And you might ask, well, how do you know what the ages were of those skeletons? And the answer was they looked at the dental ages. So they knew lengths of bones, dental ages, and there's databases that we found, a whole bunch of them, from all over the world, of Indian burial sites or African burial sites. And when we calculated the multipliers, again, they were pretty tight correlation. So it didn't matter if it was 3,000 years ago versus today. So the multiplier concept seems to be independent of percentile, big or small child, femur, tibia, or total length, nationality, or even generation. What it is different for is different body parts. So, for example, if you calculate the multiplier for the length of the foot, that's different than for the height multiplier, which includes the spine and the head, and the sitting height multiplier, which is just the spine, and the lower limb multiplier. So there are different multipliers for different body parts that you do have to come up with. And we published at least a dozen articles on all different aspects of the multiplier and confirming its validity, and even a prenatal multiplier and a multiplier for achondroplasia, and et cetera, et cetera. The most recent was we published in JPO in 2025 a foot height multiplier, because the foot height, the height from the ankle to the floor, is different multiplier than it is for the tibia and the femur, a little bit, but turns out it's not that clinically important. We derived a whole bunch of formulas as to, given this information, how to use it to calculate timing of epiphysiodesis. And you get these very complicated formulas that we used to teach at our courses, and we would give people these multiplier cards. There was a card for the leg, there was a card for the arm, there was a card for sitting height to represent spine and height, and people would carry around these cards, in a rubber band, and have to do these complex calculations. But then at one point we figured, everyone has a computer in their pocket. And so, instead of being in the Stone Age, we should be in the Space Age. So we took all these formulas and all these charts, and we put them into an app, which we now all know and love as, or hate, I don't know how you feel about it, but as the multiplier. So that's, anyway, how it all was derived and how it started. So you can do it with pencil and paper. Dr. Paley has his version of an app called Paley Growth. Ours is called the Multiplier, available for iOS and Android. And there's also some Excel spreadsheets that have been published by Sanders and by Scott Nelson in JCO 2016. So there's lots of different ways to do it, on a PC, on your pocket, or pencil and paper. This is Dr. Paley's Paley Growth Multiplier. This is our version. We added some additional resources into there. I already showed you this example of boy age 7, 6.3 centimeters LLD. The multiplier for a 7-year-old boy is 1.57, so his predicted discrepancy is going to be 9.9 centimeters. So this doesn't, unlike the Moseley method that required 3 visits and making a chart, you can answer the parents' questions on 1 visit. And so parents are very happy about that. They're very impressed with that. And of course, nothing's 100% accurate, but it's pretty close and close enough for we call government work. And that's this is how it works. You go to congenital, and then there's a little data sheet that you have to enter the age and the leg length discrepancy, and you hit the calculate button, and then it gives you your answer in inches and in centimeters, because in the United States we use inches. Timing of epiphysiodesis has a more complicated formula. We come up with a multiplier at the age of epiphysiodesis, and that's how we derive the timing. And it has to do with the length of the leg at maturity, and also epsilon, which is a desired amount of correction for the discrepancy, and a constant based on if it's femur, tibia, or both. And those were the constant lines that were on the Moseley graph, the slope that you use for femur, tibia, or both. But anyway, but that's kind of a complicated thing, and if I ask anyone to fill in this formula and do the calculations, there's a pretty good chance you're going to make an arithmetic error. So instead we do, let the computer do the work, the heavy lifting. So we hit lower extremity, timing of epiphysiodesis, and then once we get to timing of epiphysiodesis, we come up with this data sheet. It wants to know the bone, sex, the age or date of birth. It'll calculate it, a current length of the longer bone, and the desired amount of shortening based on your previous calculation of what the leg length discrepancy is going to be. And if you put all that stuff in and hit the calculation button, it tells you that you should do the epiphysiodesis at 11 years and 6 months of age. And I recommend that if you do this, you should use the skeletal age rather than the chronologic age, because you get better results if you do that. We published in JPO 2005 a validation of this method. And if you look at skeletal age versus chronologic age, they kind of correlate until around adolescence, and then they start to separate. So if you want to get better results, you should use a chronologic age. In fact, Jim Sanders published a paper looking at the multiplier method for predicting limb lengths in children, and found that if he used the skeletal age, the results were more accurate than if you used chronologic age. We added some additional resources in here. For example, there's the hand bone age, not the full Gruelich compile, but the HSS short form. And this is really quick and easy with one x-ray of a hand and just going around the circle. It starts at age 12.5 for boys and age 10 for girls, but whether or not you've got the various signs of the hook of the hamate, the ossification of the distal radius, and the closure of the epiphysis, so forth, you can tell what the bone age is very quickly. It's a lot easier than flipping through the Gruelich compile atlas. That's kind of painful to do that. We also included elbow scoring system. This is Demiglio's elbow scoring system, so we have that as well. And I would just point out, this is not our app, but there's an app from Ray Liu from Cleveland, from his hospital, where they came up with a skeletal age app, which is actually quite good. And he has systems for doing skeletal age based on shoulder x-rays, hip x-rays, elbow, knee, hand, calcaneus, and wrist. So that's pretty cool. I sometimes use that as well, but they're a little bit unwieldy, I must admit. This is, if you hit the knee system, you have to choose between the pre-adolescent Fell's knee system, the modified Fell's knee system, or the abbreviated Fell's knee system. So it gets pretty complicated. And then there's a whole set of measurements that you have to do. This is just one page, but there's like 6 pages that look like this. And if you're doing research, I think it's a good thing to have. So the multiplier is a free download. We've had 101,060 downloads since 2011, last count. Available for iPhone, iPad, iTouch, and we're up to version 8, which came out, and it's also on Google Play. And we're still modifying it and trying to improve it and fine-tune it. So that was just a little quick intro to the multiplier. And if you have any questions about it, I'm happy to field questions. Every once in a while, I get an email out of the blue from someone in Indonesia who's got a question or something's not working right, and we try to fix it and make the next version better. So that's it. Thank you.